Good morning to our beloved lecturer, Puan Noria, and fellow classmates. Today, my group and I would like to present our topic on Traverse Total Station. Before we begin, let us meet the group. Hi, my name is Ketisa Anarchisopis and my metric number is 01DKA20F2008.
Assalamualaikum to my lecturer and hi everyone. My name is Muhammad Faiz bin Muhammad Firdaus and my registration number is 01DKA20F2015.
Hi everyone, my name is David Bekaho and my metric number is 01DKA20F2031.
Assalamualaikum and hi everyone. My name is Muhammad Daniel bin Nusfizan. My metric number is 01DKA20F2030.
Assalamualaikum and hello to everyone who watched my video presentation. My name is Fadili Amar bin Hamad and my registration number is 01DKA20F2014.
Okay, let's get started. So, introduction. What is traverse? Traverse is a geometrical figure consisting of series of consecutive survey lines is called traverse. Points joining these lines are called traverse points. Traverse consists of angle and distances. What is traversing? Traversing is that type of survey in which a number of connected survey lines form the framework and the directions and lengths of the survey lines are measured with the help of an angle measuring instrument and tape or chain respectively. It is a quick and easy way to establish horizontal control, especially when the lines of sight are short owing to heavily built up areas and unable to apply triangulation and trilateration. These following are the purposes of traversing. First, surveys of properties to locate or establish boundaries. Next, for topographic mapping surveys by using supplementary horizontal control. Third is for location and construction layout surveys. And the final one is photogrammetric mapping using ground control survey. There are two types of traverses. They are closed traverse and open traverse. Closed traverse is when the lines form a circuit which ends at the starting point, while open traverse is when the lines form a circuit ends elsewhere except starting point. The objective of this presentation is to understand what is traverse surveying, principles of using total station, interpret the total station error, describe the basic principle of measurement and total station system, and finally to explain the latest development of total station and the usage of this instrument in civil engineering work.
Today I would like to explain about the equipment that we use in traversing. So stay tuned with me. Okay, the first thing that we use is a total station. Total station is a modern surveying instrument that integrates an electronic theodolite and in other multipurpose surveying instrument based on electronic distance measurement or EDM. They can measure distance angles, elevation with a high level of precision, and the data collected by a total station can be transferred through a USB port into the computer where it can be viewed and analyzed easily. Okay, next is compass traversing. Both for bearing and back bearing are measured and required correction for local attraction are applied. If any closing error is obtained while plotting of traverse, then Bowditch's rule is applied for the adjustment of error. Okay, next is plan table traversing. Is a equipment set up at every traverse station one by one in a clockwise or anti-clockwise direction. The side of each traverse station are drawn on paper to a suitable scale. If there is any closing error, graphical methods are used for this adjustment. Okay, this one is a tripod. The tripod serves as a tool to place and stabilize the total station during the shear measurement work is carried out. Okay, next is prisms. Prisms reduce the scatter of the beam as it is a reflect back to the total, which allow for both and a more accurate measurement and a longer range that the measurement can be made. Okay, this one is hammer. Hammer serves as a tool for knocking and immersing the picket into the ground before the measurement work shear start. Okay, this one is a picket, and the last one equipment that we use in traversing. Picket serve as a tool for marking the total station to ensure that the laser on the total station is directly above the point marked on the picket before the measurement work is cut. So that's all for me. Thank you.
In this group, I will be in charge to explain about field work procedure for traverse station. Okay, so this is the diagram of the traverse station. So next, the first one is total station is placed at station V, while the prism is placed at station U. The front bearing has been recorded at 128 degree 0.04 minute and 44 second, and its distance at 472.74. So next is total station is then placed at station U, while the prism is placed at station T. The front bearing has been recorded at 258 degree 34 minute and 22 seconds, and its distance is at 364.55. Total station is then next placed at station T, while the prism is placed at station S. The front bearing has been recorded at 309 degree 5 minute and 38 seconds, and its distance at 347. Total station is then placed at station S, while the prism is placed at station V. The front bearing has been recorded at 60 degree 21 minutes and 26 seconds, and its distance at 292.94. So next, first step is tripod setup. So the legs of a tripod should be evenly placed. The tripod head should be somewhat level. The survey point should be exactly over the head. So step 2 is mount instrument on tripod. Mount the instrument on a tripod. Use a centering screw to secure the instrument while bracing it with the other hand. Before leveling, insert the battery into the instrument. Step 3. Focus on survey point. So we should focus the optimal plummet on the survey point. So next is step 4, which is the leveling the instrument. Center the survey point in the optimal plummet vertical by adjusting the leveling foot screws. Adjust the tripod legs to center the bubble in the circular level. Turn the instrument until the plate level is parallel to two of the leveling foot screws after loosening the horizontal clamp. So next is use the leveling screw to center the bubble. The bubble will move towards the screw that is cranked clockwise. Turn the instrument 90 degree and use the third leveling screw to level it. Center the survey point in the optimal plummet by freeing the centering screw and moving the entire instrument. After relighting the centering screw, double check that the plate level bubble is in level in many directions. So next is step 5, electronically verify leveling. Turn on the instrument by pushing and holding the on button for a few seconds. You should hear an audible beep. The MEAS screen will appear as the first screen. Choose the tilt function. Center the electronic bubble by adjusting the foot level screws. Repeat by rotating the instrument 90 degrees. So next is step 6. Adjust image and reticle focus. Release the horizontal and vertical clamps and aim the telescope at the light backdrop with no features. Fine-tune the reticle, for example, crosshair. Focus until the reticle picture is clearly focused. Point the telescope towards the target and adjust the focus ring until the target is properly focused. Test for visual shift by moving your head from side to side, for example, parallax. If there is severe parallax, repeat the reticle focus step. Note, we should take a note, is when the instrument operator changes, the reticle focus may need to be adjusted. So that's all from me. Thank you.
My function in this group is to explain the data collection and edit this all video part. Today, I will explain to you about data collection in my group. You can see this picture in this slide. The line UT is distance 364.55 meters and the bearing is 258.34.22. Second line is TS. The distance is 347 meter and the bearing is 309.05.38. The third line is SV. The distance is 292.94 meter and the bearing is 16.21.26. The last line is VU, 472.74 meter and the bearing is 128.04.44. All total distance is 1,407.23. The next slide, my friend Fadli will explain about analysis and data collection. Thank you.
Now in my group, I will discuss to explain about analysis and data calculation. Now this slide is about formula for travel survey. The first formula is how to calculate latitude equal distance cos bearing. Formula number 2 is how to calculate departure equal distance sine bearing. And formula number 3 is correction use bowdish. Correction of latitude equal distance of line or station per total distance multiple error of latitude. Correction of departure equal distance of line or station per total distance multiple error of departure. Now formula number 4 is how to calculate error. Total plus positive minus negative or total not minus total sort or latitude minus departure. And last formula is formula number 5 is linear mixed closure equal error of L power of 2 plus error of G power of 2 per distance equal 0.069 power of 2 plus 0.081 power of 2 per 1477.23 equal 8.5028 multiple 10 power minus 5 equals 1 per 8.5088 multiple 10 negative power negative 5 and the total is 111,760.83. Thank you very much.
Alright, so the comment that we have for this presentation is the procedure for balancing a closed traverse. The first is compute the sum of the measured interior angles and balance them. Second, if azimuths were recorded, then translate them to bearings. Third, compute the latitude and departure of each of the courses. Fourth, determine the area of closure in both latitude and departure and the linear area of closure. Fifth, determine the ratio of error and compare with the allowable ratio of error. Sixth, compute the corrections in latitude and departures using the compass rule if error is allowable, which states the correction in the latitude departure of a course is proportional to the total error in latitude departure as the length of the course is to the perimeter of the traverse. And 7. Subtract the corrections in latitude and departure for each line from the latitude and departure for that line to obtain the adjusted latitudes and departures. 8. Compute the total latitudes and departures around the course. And finally, number 9. Compute area of closed traverse by coordinates. In conclusion, this presentation has helped us a lot to understand what is traverse surveying, the principles of using total station, how to describe the basic principle of measurement and total station system, how to explain the latest development of total station and the usage of this instrument in civil engineering work, and how to interpret the total station error. That is all from us. Thank you.